Welcome to our lesson on approximation. In this particular lesson, we're going to look at the two components of approximation, which are rounding off and standard form, which is also sometimes called scientific notation. Standard form or scientific notation. Now, approximation is simply a way of presenting a given value to the nearest accurate unit where the actual figure is not necessary or is not possible in a given situation. So there are certain numbers that may be difficult to state accurately, either because they are too small or because they are too large. It's not practically possible to provide an accurate reading of such a number. So in such cases, we utilize the concept of approximation to give a general idea of the closest correct value which can represent such a particular number. Now, we approximate a number by rounding it off or by writing it or expressing it in standard form. So these are the two ways that in which we can approximate a number. So in this particular lesson, we will start with the first concept, which is the concept of rounding off, so that we can understand what rounding off is and how we can round off a number. Now, a number may be rounded off based on 4 different principles. Number 1, we can round off a number with respect to a concept called significant figures. So we can round off significant figures. We can round off a number with respect to its significant figures. That's context number 1. Significant figures. Number 2, we can round off a number with respect to a number of decimal places. Of course, generally we operate in the decimal number system, which means our numbers are in base 10. That's why we are referring to decimal places. And then number 3, we can round off a number with respect to place values. With respect to place values. So we'll quickly run through these 4. The 4th one being with respect to units of measurement. So sometimes the number can be a measure of a particular quantity, unit of measurement, so we can round off a unit of measurement as well. Now we can look at these contexts one at a time. For significant figures, we have to consider two types of numbers. We can look at whole numbers on one side, significant figures. Okay, sorry about that. We're going to look at significant figures and just how we can understand the different ideas about significant figures. Now, we know what the word significant means. Significant simply means important. So when we say significant figures, we are simply talking about important figures. Now, in general, the digits that we use are all considered significant or important, except one digit whose significance depends on its position. So the digits that we use in the decimal number system are 1 up to 9. Okay, the digits 1 up to 9 are important, meaning that they have a value of a given measure. So a 1 is a significant figure wherever it appears. A 2 is a significant figure wherever it appears, because these are numbers that are counting the magnitude of a particular quantity. So in short, non-zero digits are significant. Okay, this is my digit here. Non-zero digits are significant. So if you have been given a number and you want to determine how many significant figures it has, you first count off all non-zero digits. Those are automatically significant figures, because they are giving you a specific magnitude of a quantity. So we are saying the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are all significant figures. So any number that will have these digits, it means you read those units as significant figures. Now, it depends on where these digits are appearing. They can appear in a whole number or in a decimal number. These digits can appear either in a whole number or in a decimal number. So if you are dealing with a whole number, the issue of the significance of 0 comes in. 0 is only considered significant when it is between non-zero digits. So 0 that appears, a 0 that appears between non-zero digits is significant. So you only count a 0 in a whole number when it is between non-zero digits. So what we mean here is if we have a number like 203, this number has 3 significant figures. Even if we are saying non-zero digits are significant and 0 is not significant, but because of its position here, the 0 is between non-zero digits, it means in this case we are going to count it as a significant figure. Okay, but if it is after the last non-zero digit, like in 230, this one will count that it has only 2 significant figures. So a 0 that comes after the last non-zero digit is not considered significant. It's just a placeholder. So this one has only 2 significant figures, which is the 2 and the 3. And sometimes we have a way of writing numbers starting with a 0. For example, in codes, maybe a code, a password, a receipt number, and such kind of measures or coded units. If a number starts with a string of zeros, those zeros in front of non-zero digits are not significant. So it means in this case 023, it means the first 0 is also not significant. So we'll only count the 2 and the 3. So you can see in this scenario involving whole numbers, that 0 is only considered significant when it appears between non-zero digits. It is not counted if it is the last unit at the end of a non-zero number or when it appears in front. That is the significance of 0 in whole numbers. Then in decimal numbers, if the number has a decimal point, that means it's a decimal number. So for decimal numbers, of course, a 0 that is between non-zero digits will also be significant, just like we saw in whole numbers. So 0 between non-zero digits is significant. Zero between non-zero digit okay, a 0 that is between non-zero digits is significant. But apart from that, a 0 that is after the last non-zero digit, that one is also significant for decimal numbers, okay, because it gives us an idea of how many decimal places we want to retain in the number. So 0 after last non-zero digit a 0 after the last non-zero digit is significant. For example, if we have let's say 0.003 401, okay, So if we look at this number, of course our principle is that non-zero digits should be counted, but we are also going to include these two conditions on the significance of a zero in a decimal number. So the zeros that are before the first non-zero digit, those are not considered significant. So in this case, this chain of zeros before the first non-zero digit, all those are not considered significant. Just like we saw in whole numbers, that the zeros that come in front, okay, before the first non-zero digit, those are not counted. So in this case, the 0.00, those are just, units to return the place value of these numbers that we have. So starting from 3, that's where the significant digits are. So the 3, the 4, and 0, 1, like here we have a 0 which is between 4 and 1. So that 0 is going to be counted, which means this number has 4 significant figures. Okay. If we write, for example, 0.0100, this one has 3 significant figures. The reason is that we are going to count the 1, which is the only non-zero digit which we have. We'll count the 1 and the zeros after, according to this condition. We'll count the 1 and the zeros after the last non-zero digit. So it means those two zeros are significant. The first ones that are in front, 0.0, those are not significant. So that is the first principle that we look at when rounding off. You need to know the significant digits in a particular number, so that when we want to round off with respect to significant figures, you will be able to understand where exactly you are supposed to base your estimation or your approximation of the number. So we are going to end this lesson here, which has basically looked at significant figures, and then we'll pick it up in our next lesson.